Okay. Hello and welcome to this presentation. Hope that everyone had a good day so far. We are coming close to the final of the conference. And for this presentation, we'll look into some methods to bypass the antivirus using BadUSB, like this little device right here. But before going forward with the details, just words about myself. I'm a pen tester, founder of Zero Attack Security, and also founded the Romanian Cybersecurity Training Center of Excellence. I'm also a trainer for foreign institutions and organizations like Pentagon, Polish Military CERT, and much more. Speaker to some conferences across the globe, and part of the SC Council Ethical Hacker Scheme Committee, which means that I'm part of the group that creates the exam and also the syllabus for the course. Yes, so the agenda for today, we'll look into some AMSI bypass technique to embed on our device, execution policy bypass on Windows, how to develop our own payload runner for the shell code, and all of those will be put on this device, this little device. Then some tips to persist into the device that will compromise using the BadUSB, a live demo to see how the things work, and then some prevention tips. So we have the following scenario. Bob goes smoking in the smoking place at its office building, and he found a little device, either in the smoking place or in the parking lot. And what he thinks? He will take the device with him. And Bob goes upstairs to his computer and just plug the device, the little BadUSB, into his computer. Once the BadUSB is plugged, there will be a reverse shell back to the attacker. But how did this happen? Because Bob has Windows Defender enabled. Bob is actually a low privileged user on the workstation, and the company policy disallow removable media storage to be inserted into the computers. So how it is possible? But before going forward with more in-depth technical analysis of the attack, let me ask you one question. How many of you do you rely on Windows Defender? Hands up. Okay, so plenty of you. How many of you are confident in this decision? Okay. Yeah. So today we'll see another reason why we should not use some antivirus products that are free or trial, and one reason why antivirus should not be our own, our single defensive mechanism within our personal computers or work-related activities. So let's see the scenario of the attack. Basically, we have the AMSI bypass, which is the main component of evading the antivirus. Then execution policy bypass, which is a logical issue at Windows level, also was reported to Microsoft, but they didn't consider it worth their attention. So I decided to do a talk about it. Then we'll develop the payload runner, which will be actually our code that injects our malicious payload directly into the memory. Then some post-exploitation tips to see how we can keep our persistent into the compromised device without being detected in the future. So let's go firstly with the AMSI bypass. So before looking how can we bypass this protocol, we firstly need to know what is this protocol actually. AMSI stands for Anti-Malware Scanning Interface, and it's like a middleman between our antiviruses or endpoint protection products and the scripts that we are running on the Windows workstation. For example, every time you run a PowerShell script, the AMSI will send the PowerShell script to the Windows Defender engine, for example, to be checked for any malicious signatures, any malicious behaviors. So the AMSI uses AMSI.dll library, and more specifically, it uses the AMSI scan buffer to send the PowerShell script to the antivirus. So what we'll do in our bypass, we'll actually manipulate the function that sends the scripts to the antivirus in order to return every time that the file is legit, is valid, does not contain any malicious indicators, which will allow us to run malicious scripts actually on the Windows workstation. So, starting firstly, we will need to define some Windows native API functions within our PowerShell payload. We will define the getproc address, load library, and virtual protect. We'll translate those APIs using add type in PowerShell, because this structure is not known by PowerShell. This is actually a C# code which will translate to PowerShell using the add type as seen right here. Then the second step will load the AMSI.dll library, which contains the AMSI scan buffer function into the memory. We'll retrieve the address of the AMSI scan buffer function, and then we will try to build a value that will replace the scan results of the function. Why are we building this value right here? We'll see in the upcoming slides the explanation for this value. Then, using Marshall copy, we will replace the address. And here is the explanation for this value. So, if we take a quick look over the documentation for AMSI scan buffer function, we'll see that it has a parameter called AMSI result. If we dig deeper into the AMSI result parameter, which is actually the result after scanning the file or the script for any malicious indicators, we'll see that we can replace the age result, which I skipped right here. So actually the function returns s_OK if it succeeds into scanning the file. If there are any issues when scanning the script or the file, it will return an error, which is age result error code. And we'll take a look over the values that can be taken into the age result score, and we have one for invalid arguments. For example, we can call the AMSI scan buffer right here. We can call AMSI scan buffer with missing arguments, and in this case, it will return this value as an age result. But why do we want AMSI scan buffer function to return an age result value? We want to return an age result value because it will stop the scanning of the script or the file if it returns an age result, which means that our script will be passed to execution, whatever that it may be, a malicious one or a legit one. So this was taken from the official documentation of the age result values, and we're building this value right here. Here it is, the sequence where we build our age result value. And here it is our final MC bypass payload. Let me ask you a question. What would you do in this case? Because this one is detectable. Any ideas? Okay, yes, basically obfuscation. And do some replacements and mathematical operations on the strings. And we transform the payload like this. As you can see, it is pretty different, and we have the strings are constructed during the runtime, so they are not constructed as static payload. They are constructed during runtime. So we have the AMSI payload. Next, we want to take a look into execution policy bypass. Have you ever gone through this error when trying to execute PowerShell? This is execution policy on Windows. And why it is disabled? It is disabled because we are running the script as a low privilege account. So, in this case, we, as Bob, as a low privilege account, are not allowed to run any PowerShell scripts. But Windows allows us to set our own execution policy for our current user to unrestricted, which means that allows us to bypass by default the execution policy. And this is like a flow in Windows by default. And this was obviously reported multiple times to Microsoft, as I've talked with many people about this issue. But Microsoft doesn't consider this as a security issue. So, yeah, what to say? I had no words when they said this. So we can actually run this PowerShell command right here within our payload in order to bypass execution policy and to be allowed to run PowerShell scripts as a low privilege user. Next, the third step would be the payload runner development, which is one of the most important steps within our exploitation, because most of the antivirus products will catch our payload as it is, but here we can do some tricks in order to have a fileless execution of the payload and eject it directly into the memory. Firstly, we'll define a lookup func, which we will use later within our PowerShell payload in order to search for other functions within, not functions, but assembly references in memory. Then the getDelegateType function in PowerShell. Why we do this? Because PowerShell actually does not know about some variables types that are defined in C#, like pointers or things of the nature. So we must define the getDelegateType in PowerShell in order to use some of the variables types that are defined in C#, but we'll use them in PowerShell. We'll not get really into details for those functions because they are pretty complex. Then we'll just allocate the memory that we need for our payload using virtual alloc right here, that we search for it in kernel32.dll library using the lookup func that we defined right here. And after that, we use something like MSVVeno to just generate a Meterpreter reverse shell, which actually Meterpreter and reverse shells are easily caught by any antiviruses nowadays. So let's see if our payload will be catched or not. And then we define our our shellcode that we previously generated using MSV Venom. We define it in PowerShell, and using again Marshall copy, we copy the shellcode directly into our previously allocated memory, which is right here. Okay, and then just execute it using the create thread function from kernel32.dll. We search for the memory address of this function using lookup func. And that's our final payload. We will see it once we execute from BadUSB. But before putting everything on this little device, let's take a look how we can play with it. So, a quick introduction to BadUSB. What is a BadUSB? So, it's not a removable media storage. It's actually a simulation of a mouse and a keyboard. Basically, it's an Arduino-based USB that allows us to simulate a mouse and a keyboard. And how can we put everything, the whole script on it, the payload that we discussed previously, how can we compile it to our BadUSB? We have two main ways to do it. Firstly, we can use DigiSpark scripts, which are basically the scripts used on Arduino, and they require C++ knowledge because the syntax is actually C++. And I'm not that really good at programming, so I found another quick way to do it through Ducky scripts. What are Ducky scripts? How many of you heard of Rubber Ducky before? So, almost everyone. So, Ducky scripts are the scripts that are run on Rubber Ducky. But why have we not used Rubber Ducky in this case? The answer is pretty straightforward. A BadUSB, it's almost 5 times cheaper than a Rubber Ducky. So, for example, you can drop 10 of them in a parking lot, and it will be the same value, the same price as you drop a single Rubber Ducky. So that's the answer for this one. And Ducky scripts are pretty beginner friendly, and the syntax for them is pretty simple. And once we have a Ducky script, we can use something like Duckuino from GitHub, which is an open source tool used to convert the Ducky script into Arduino format. And just a quick introduction to Ducky scripts, to Ducky script syntax. So actually, what we want for our BadUSB to type on the computer that we compromise will be the string followed, the string after the string variable. So as you can see in this example, you can type PowerShell.exe, but before that you should put the string variable in order to type that one into the compromised computer. We have delays, we have comments, we have also repeat loops, and very important, the special keys on the keyboard should be written as they are on the keyboard. For example, Enter, Control, Tab, Shift, and so on. The guy is the Windows key, actually, and we can make our BadUSB also to simulate movement of mouse, like to move the pointer to some coordinates on the compromised machine, or to press the mouse buttons. And let's take a look at some post-exploitation persistent tips. Firstly, what you'll see in the demo is that we'll run a Meterpreter reverse shell. Using Meterpreter can allow us to migrate our process to another process that is run by that user using the migrate command in Meterpreter. We can migrate into an explorer.exe process or some other legit process that is run by Bob user. And now let's take a look over the demo. Hope it will help. It will run, actually. 1 second, because I must connect to our Kali here. Okay. Kali. Open. Kali. Okay, we'll use. Oh, let me make it bigger. Okay, MSV console in order to open Metasploit. We wait. The Kali box is pretty slow. Okay, we'll use the exploit multi-handler module from Metasploit. As payload, we'll set the payload to Windows 64 Meterpreter reverse underscore TCP, pretty basic reverse shell. Set listening host to 0.0.0.0, okay. Set listening port to 443. Okay, let's check if Windows Defender is running. Okay, we have real-time protection enabled. We'll do like a quick, like this. Okay, we'll run our Metasploit module, and here is the BadUSB. Inserting this one. 1 second. Okay, let's see. Okay, trying to run PowerShell. It's pretty slow here because it is like in a proof of concept mode, but in real life it can be like in milliseconds. Okay. Now we look to our Meterpreter, and here we have a shell. And where am I? Okay. And real-time protection is running for the Windows Defender. This attack, I used it in multiple real-life scenarios, and it's working pretty good. Let's see next, prevention. So, some methods to prevent for those types of attacks. Firstly, PowerShell should be disabled for end users, unless they are developers or they strictly need PowerShell to be run. Access control is on USB physical ports, and you should consider buying an advanced endpoint protection solution. Don't rely on Windows Defender. And user awareness, security awareness training for the users. And some statistics regarding other antivirus vendors. I took a look into the free trials from 20 antivirus vendors, and here are the statistics. Firstly, Microsoft does not consider this a security issue. They allowed me to do talks based on this issue. So here we are. But regarding other vendors, which I cannot disclose because we are still in discussions, 7 from 20 spawned Meterpreter reverse shell, and all those 20 antivirus vendors are basically well known. 9 from 20 spawned a normal reverse shell, and only 4 antivirus vendors actually blocked the exploitation attempt. And thank you very much. Do we have any questions or curiosities? Yes, please. Yes. Sorry, can you repeat that one, please? Can you, please? I'm not an English native speaker, so it's pretty hard for... Yes, string concatenation and normalization. Yeah. And for the PowerShell AMSI bypass, the invoke obfuscation was used, which is a tool from GitHub that you can use to obfuscate another PowerShell scripts. Yes, and for the MC bypass, 1 second, it's not only the strings that are, so the strings are not really in plain text. As you can see here, the strings also takes other formats, and during runtime they are converted. And if you want to do more advanced, you strip the AMSI scan buffer function, and you do like a root or SOR encoding during runtime. Yes, but when it comes to encryption, some antivirus products catches the encryption functions in static analysis. Yes, please. So basically, you can do the OSEP certification and syllabus from Offensive Security. Offensive Security Experience Penetration Tester. It's a very good way to learn how to abuse Windows APIs. And regarding exploitation of those Windows APIs was basically because I'm very involved into red teaming assessments for different clients, and I have to find solutions to bypass their products, and most of them uses Defender, unfortunately. Yes, you have to have a little bit of knowledge into C#, and very important to know how to read the Microsoft official documentation for some functions, because it's pretty hard sometimes to read the official documentation from Microsoft. Sorry? No, so C# when it comes to those things. So, any other questions or? Okay, then thank you very much.